Hi, and welcome everybody to the first video for Field Power Systems. Today we're going to be covering ground faults, and this video will cover residual ground fault and what it would look like on a 4-wire system. The other two types of ground faults we'll cover in a separate video for each one is source ground and zero sequence ground. These are very common ground fault schemes you'll find on low voltage and medium voltage systems. So let's say that we have the system. This is the transformer. This is A phase going into a breaker, B phase going into the main breaker, and C phase going into the main breaker. And then you have the neutral coming out as well. This is known as the neutral isolation bonding jumper, or neutral bonding jumper. And then right here, this is the neutral CT. Now, how this residual ground fault would work is, say you have a single phase load running on this 4-wire system. You have current running on A phase. It would, if it's single phase load, what would happen is the current would return back on the neutral, and the neutral CT, which is wired to the breaker, would pick it up, and the breaker would realize that the current that's coming out on A, all of it is returning back on the neutral. In that case, it wouldn't trip. It would trip if this current didn't come back on the neutral, because that means it's going somewhere else, i.e. it's going to ground. One thing that we do in the field to check this ground fault test is we jumper A phase to the neutral, and then we push current through A phase, and then it makes sure that it returns back and passes through the neutral CT. Once that happens, the breaker shouldn't trip. Okay, now if the breaker does trip, you're going to want to check that obviously you have the ground fault enabled on the circuit breaker to the right setting level, whatever you're testing at, and you're going to want to, the most important thing is check the polarity of the CT. Now, you can figure out rather quickly that the polarity CT is incorrect because it'll do a half trip. So say you have the ground fault here set at 250 and it trips at 125 amps. The reason why it trips at 125 amps is because now it's seeing 125 amps coming this way, and it's seeing 125 instead of coming back this way. Now it is, if the polarity is incorrect, it'll see it going that way, so it'll add it. So that's why you'll get half a trip. And then last but not least, this is very important right here. This is the neutral bonding jumper, and you're going to want to make sure that the neutral bonding jumper is after the CT, neutral CT, because if it's before or if it's downstream of the CT, what would happen is the current would go say it's down here. So say the neutral bonding jumper is incorrectly placed right here. That would cause this current to go to single phase current loads to go to single phase currents to go to ground before it reaches the neutral CT, which would always cause the breaker to trip. So you're going to want to make sure that that's not the case. And how you do that is you would disconnect this right here. There's actually links in here, and most manufacturers' gear, you can disconnect it and you can measure and do an insulation resistance test from neutral to the actual ground bus bar. Now, if you do get it's a closed circuit, you're going to want to go back to the transformer, because sometimes they do actually ground XO, which is the neutral, on the transformer to the frame. And if that's the case, you want to make sure that that's what they did and it's not grounded somewhere downstream of the CT. So just a couple things to keep in mind. Now, say this was an old, outdated system, and it was just a 3-phase. Some of the older systems, all they have is 3 phases, but they run single-phase loads. In that case, what happens is one of the phases, the current returns on one of the phases. So it would still work the same, except the current wouldn't return on the neutral. It'd say return on B phase. So as long as the current leaving the breaker is the same as the current coming back through the breaker, whether it's through the breaker or through the neutral CT, then it won't trip. And that's residual ground fault for you guys. If you have any questions, feel free to post, and any feedback as well. Thanks.